that we can do with our Raspberry Pi for good and evil, or just evil?
Good.
All good. Look at this guy. Look at this guy. Blue teamer. Let's give you all a big round of applause.
Thank you, thank you. All right, so I think everybody and their brother has a Raspberry Pi laying around their house, and I mean, even the oldest one will do the trick in this case. So I sat down one day and I was trying to figure out, okay, what's a good project that I can really kind of stretch my wings on? And I said, well, let's make a wireless sensor. And this isn't the first time I've tried to kind of tackle this. In any case, my name's Joel Kirshner. I'm kind of blue teamer, a little bit of everything geek. And this is kind of my motto, which is, it's not the end destination that is the goal, it's the journey. And really, it's all the stuff you learn when you're trying to accomplish a goal. That's really the benefit of doing anything. Come on. All right, so we have our Cards Against Humanity theme here. We've got what is the, and we have a couple different options here. Which one do you think it is? Oh, come on. Okay. Well, I'll choose for you, because I think 433, White Pi is the best option there, so we'll do that. All right, and so what is it? The 433 White Pi is a Raspberry Pi, and then it also has the ability to go out and it runs Kismet wireless, so it's giving you an idea of what kind of Wi-Fi you have in the area. And then it also has a RTL SDR, a software-defined radio. And software-defined radios are really cool because they have this really big span of bandwidth that they can look at, and then you can pull that in digitally into the operating system and pull out interesting stuff. So yeah, this is a very annoying. Okay. So I wanted to kind of combine these two things, and I wanted to do so in a very small form factor. And so this is the device right here. Essentially what this is, you have a RTL SDR, which this one I got off of rtl-sdr.com, I believe, and they sell one for about 25 bucks. Now you can get these all over the place. I mean, they're super cheap. They're anywhere between 10 to 25 to $35, depending on where you go. RTLSDR.com has one for about 25, but it's temperature stable and has a really good tuner. Can we switch to the other microphone? Okay. Well, while they're working on that one. Another thing is that because it's a Raspberry Pi, it's very energy efficient. So most of the time in the past, whenever you've done war driving, you'd had to go out with a laptop. Well, laptops are very bulky. You have to keep it open. You got all the power saving features you got to fight. And it's not very good that a laptop typically isn't very good headless. So a Raspberry Pi is low power. You can hook in just about anything that's supported into Linux into the USB ports. And because it is running Linux in the background, you can pull that information in and pull it into the logging mechanisms and really make good use out of it. So what kind of stuff that do we have to pack in here to get this all to work? As much as I'd be interested in German dungeon porn, no. So one of the key things is that you can pull down data, but there's a couple key things that you'll be missing with that data. One, a Raspberry Pi is missing something very important. It does not have a real-time battery backed up timer. So when you're logging, when you turn off the Pi and turn it back on, it doesn't know what time it is. So the only thing it has to go off of is that whenever it shuts down, it will record what the time was at the time, and then it'll add something random to that, and then when it boots up, that's what the time is. Thank you. Is this better?
Yeah.
All right, thank you. So that's one thing that you have to take into account when you start using a Raspberry Pi to do anything, is that you have the time issue. So there's a couple ways we can get around this. One of them is with a GPS. And so GPS doesn't always, so the GPS is cool because it gives you a whole bunch of awesome stuff in real time. So it tells you where you're at, tells you your altitude, but it also tells you the current time, and it's very accurate. So the benefit of using a GPS on any type of sensor is that you're going to get really good time in addition to having it geolocated. The other thing is that you still want to have a real-time clock with that, something battery backed up. And so, because when the Raspberry Pi turns on for the first time, it's going to default to that old bad time, and so your logs are going to be all over the place. So there's two key things. That's kind of my takeaway from all of this. You also need the RTL SDR. Now, the one off of RTLSDR.com has the ability to hook on a third-party antenna, which is very important. And then you can go through and set up just about any type of Linux-supported Wi-Fi device. But the trick is that 802.11g and the 2.4 gigahertz spectrum is well represented, but it's really hard to find something that handles 5 gigahertz. So good luck with that. And then we talk about accessories, things that makes this even cooler. So we talked about the real-time clock. Another thing that's really cool is CPU heat sinks, because when you overheat a Pi, it starts getting weird. You start getting memory errors and that kind of stuff, and so it's very important to kind of keep your sensor cool. Let's see here, what we got. So in short, the software needed is that I'm using Raspbian Linux, and the other thing that you need is the RTL 433 project, and that's found on GitHub. And then your standard install of Kismet. The RTL 433, the cool thing about that is it hooks directly into the software-defined radio, and then it tunes it. It tells it to go to the right frequency, listens to 433 megahertz, which is where a lot of Internet of Things devices hang out. And then it is able to decode those, and then it'll take what is decoded and turn that into a JSON string. And then what I'm doing with that information is I'm pulling that into syslog. Now Kismet also, it's going out there and it's pulling in all the information about all the wireless access points in the area, but it's also dumping to syslog because there's a syslog plugin. So syslog is important because just about everything supports it. And so if you're turning this into a tool for the blue team, you need to get this information in. You need to have a live stream of information from this sensor that's telling you, okay, what's going on in this area. And you're setting a baseline using that information. Plus, you have your GPS on board. And I created a Python script that pulls in the GPS logs from those two sensors, and then it mixes it in with the current stream of GPS data, so it's geo-encoded. So you have this syslog stream that has GPS coordinates in addition to the log information that you're gathering. So, and something cool that you can do with this is that one of the sensors that hangs out on 433 megahertz is tire pressure monitors. And those monitors, they have a unique serial number to them. So you can potentially set this up and listen to all the people, listen to all the cars going through a certain point and picking up the unique serial numbers on their tire pressure monitors. And so you can figure out who's coming in and out of your parking lot. Not my fault. Okay, yeah, that was very uncomfortable. I don't want to do that again. Can we not do that again? All right, awesome. All right, thanks. Okay, how to build one. So rather than go through all the really boring details of how to splice this thing together, I put all my code and all the instructions on how to make this happen on my GitHub page. So please, by all means, visit here. And if you find a better way to do something, please let me know so we can update that page. Let's see here. Now, with this data, you can do some very interesting things. So we have here our options. Do we want to learn about fingering? No. But I would like to know more about that 433 megahertz frequency range. So one of the things you'll see a lot of is these automatic temperature gauges. So if you go into Walmart or any place, you have this kind of wall dedicated to midlife crises that all it really does is it gives you a sensor where you can read the current weather, and you don't have to leave your house. And they cost hundreds and hundreds of dollars. Well, rather than spend hundreds of dollars, wouldn't it be cooler just to use everybody else's sensor and have a compared, statistically correct version that you can, reference? So that's one of the things. So in this case, I'm using Graylog to pull in information in JSON format. And also because it's geolocated, I can kind of potentially triangulate where those stations are. Let's see here, another one here. I want to figure out what, poor life choices. I don't think I have any slides on my poor life choices, but I'm gonna go with Kismet. Kismet is, it's one of the original war driving tools. And the cool thing about it is it's a passive sensor, so it's listening. It's not actually sitting there beaconing out its presence. It's actually just listening to see what kind of traffic it gets. And it really makes kind of, I think it's really one of the only wireless intrusion detection systems out there. Now, it's not really intended for this in that it's just kind of a user end GUI tool that displays kind of a scrolling list of access points as you find them. But it also hooks into the GPS system, and then it's geolocating all that information as it gets it. So you can go through and get the logs, and there's a tool also on GitHub, and it's called, let's see here. So this tool is called GIS Kismet. And so you take the Kismet logs that are generated that have GPS information, and then you can make a KML map and put that on Google Maps. Or in this case, I have QGIS, and so I just build my own maps based off of that information. And so you can plot out all the access points on your favorite bicycling routes. So other things you can use this for. Because you have access to a GPS sensor, one of the cool things you can do is that you essentially have a GPS disciplined time source, which that's really important on a network. Because if you have 15 different servers, each of them, anywhere between 30 seconds to 5 minutes off, that causes a lot of problems when you're trying to figure out what's going on inside of a network. So that's one of the other things I've taken away from this is kind of the cool things about GPS and kind of other uses for it. The 433 software, it isn't limited to 433 megahertz. You can sit there and have it jump all over to key places all over the spectrum. And so not all tire pressure monitors hang out at 433 megahertz. Some of them are like 312 megahertz. I mean, they're all over the place. So you can set it up so that it'll scan through those frequency ranges and tell you all the stuff that's out there. And I think I learned out of this project, I learned Python, used GitHub the first time, which is kind of amazing. I'd never gotten around to it. And that's kind of really the things I got out of this. Does anybody have any questions? Going once, going twice. So the segue to this is that you have this data source, but you have to do something with it. And so Johnny 5 is a Zen master of working with Elk Stack. And so I think for our next talk here, he is going to tell us, now that we have a data source, what we can do with it. So if that's all, thank you very much.